Hey guys, here is the homework you had to finish. This is what we started on class. I'm going to guide you through to make sure you get your 10.1 practice. You're going to be using the Pythagorean theorem. So most of you wrote and substitute your a squared plus b squared equals c squared. Make sure you go ahead and tell me what 30 squared is. So you have to go ahead and use your calculator. So we should have, right, what it equals 900 underneath it. 40 squared is 1600 equals x squared. And then use your math, your addition to simplify this. And if you did it correctly, yep, 2500 equals x squared. And then we should supposed to take the square root of both sides. So I said it's important to have your calculator. So we're going to do control x squared, 2500, hit enter, and we get 50. So x, the missing variable, is 50. We're going to box that. So let's make sure we're setting up number 4 correctly. We know that our A is 80. Or actually, I could, if I wanted to, make 18A and make 80B. Because your A and B can be interchanged. They're the parts that make the right angle. So I could say 18 squared plus 80 squared equals my x squared. So go ahead and use your calculator. Plug in the parts. Also to get what 18 squared equals, and write it right underneath it. So if you got 324, you're on the right track. And figure out what 80 squared is, and then add them up, take the square root. Okay. All right, so when you get to this next section, you have to use your notes. And in our notes, we were given the most common triples. And if you recap, if you go back, let me see if I can find that. That was right here. Here are our most common triples. So we're going to use those. I'm going to write those down and see if we have some multiples of those. Oops. Here we are. So our most common triples. First most common is 3, 4, 5. And then the next most common is 5, 12, and 13. Then we have 8, 15, and 17. And then 7, 24, 25. Okay, so what we want to do is just check, are these a multiple of this set, of one of these sets? Well, if I look here, 6, 8, and 10 is just saying 3 times 2, 4 times 2, 5 times 2. Meaning I'm using my 3, my 4, and my 5. So this is a yes. Well, if I have my highest side, I'm looking at 7, 16, and 18. I need a multiple of any of those. Well, do I have a multiple of 4? Yeah, 16 is a multiple of 4, but that means I'm multiplying 5 by 4. So this is a no. They're not multiple. Check this next one. See if you can get the last one. See if you can determine if it's a multiple of an existing triple. Okay? All right. Then we get into our green foldable. Oh, not this one. The next set is a green foldable, where we're still using Pythagorean theorem, but now they want us to express your answer in simplest radical form. So let's do that together. This basically means no decimal answers. Okay? We're just going to make it into a smaller radical. All right, so we're still doing what we did before with Pythagorean theorem. We know here is our A, here is our B, here is our C. So we're going to substitute the parts in. So instead of writing A squared plus B squared equals C squared, we're going to put the numbers that represent each variable. So 4 squared plus x squared equals 18 squared. And we're going to do each one. 4 squared, 16, plus x squared, and then we have to get 18 squared, which is 324. Now we're solving for x. So to do that, we got to get the x squared by itself. So we're going to subtract the 16 from both sides. and get your x squared. Well, that equals 0. So x squared. Hold on a second. It froze on me. Okay, so we're going to have x squared equals 308. And then we're taking the square root. And this is when I go to my calculator and I put in that 308, hit enter. It's a decimal. Now, because I said no decimal answer, doesn't mean you round it to a whole number. It means that we have to simplify this. We got to break this down to a smaller fraction. Now, you're not too sure how to do that, like your fractions, your perfect square factors. The easiest way to do it is to break it down like you do, your factor tree, prime factorization. So you're trying to come up with two numbers that you can use to make 308. Well, also that can help you is most numbers in your think cloud, the numbers you should kind of think about to use, you should always start off with the first 4 primes. So we got 2, 3, 5, and 7. Okay. So I know 2 can go into 308 because it's even. So I'm going to say 2 times what gets me 308? Well, all I got to do is divide that by 2 and I can figure that it. And that is 154. Then I want to break this down again. I know 2 works because again we have an even number. And now when I divide that by 2, I get, I should have did that in a different color, but I'm going to break this down and we get 2 and 77. Well, I know 2 cannot go into 77, but I know 7 can. I can use that 7 in my think cloud, and that is 7 and 11. But guys, right there, because I get a prime number, I'm going to stop basically right here. Because 7 is going to be used, and unless I have another perfect square, I'm going to just, look for my groups of 2. So I know this is 7 and 11, but I look at my ends, the numbers at the very end, and I say, do I have any in common? But yeah, I have a set of 2 right here. So that means that that set of 2 is coming out of my radical. Here's my radical. I have one set of 2, so that means the 2 comes out. And what do I have remaining? The 7 and 11. And 7 and 11 we know is 77. So that 77 is what stays in the house. And there is my simplified radical. Okay. We'll do another one. Make sure you understand. First, you always start off with your Pythagorean theorem. So we're just going to substitute. Instead of putting a, we got our 3 squared plus x squared equals 6 squared. And then we got 9 plus x squared equals 36. And now we got to solve for x. So try that. Exactly if you said minus 9 to both sides. And we get x squared equals 27. And now you need to take the square root. So if you need to, come up with your factors of 27. Exactly if you said 3 and 9. Well, I can't break down 3 anymore. That's just 1 in itself. But I can break down the 9 some more to 3 and 3. And we're trying to circle groups of 2, a pair. But here's one pair. And then what's not circled is what stays inside the radical. So really, my x is going to end up being one pair of 3 came out. So I just write 1, 3. And what did not get circled? The 3 I have there. So here is our simplified answer. So same type of notion here. We are doing x squared plus 18 squared equals 20 squared. Now do each one at a time. We know the x squared is going to stay there, but what is 18 squared equal to? What's 20 squared equal to? Then do your subtraction. Take your square root. Try to do this one on your own. Now, the last section, it says, is each triangle a right triangle? Explain why. So this is when we are going to compare the longest side to the other two sides. And we're going to check to see, basically we're going to check to see if c squared equals the a squared plus b squared. Okay, so with that being said, we're just going to substitute the parts. Hold on just a second. Alright, so we know our c is our hypotenuse, that's our largest side, so that's going to be our 17 squared. We're comparing that to 15 squared plus 8 squared. So use your calculator so you can figure out what the 17 squared is and write it right underneath. Okay, so you should have 289 plus the 225 and 64. And then we have to just add those to see what we get. We get 289 for 17 squared, and then when we add these together, we get 289 because they equal, it is a right triangle. Alright, so now we just check the next one. Again, we start with our hypotenuse, the c. So we have 45 squared. We're comparing that to 27 squared plus 36 squared. That's why you need to use your calculator because you're squaring some big numbers here. So we get 220, 25. And then we have to do our 27 squared, 729, plus our 36 squared, 1296. And then we need to add those and compare it to our 2025, right? So we get 2025, 729 plus 1296. Yep, that's going to be 2025 as well. They're equal again. So this is yes. We have a right triangle. Alright, so you do 13. I'm going to see if you really understand what 13. You can pause the video, do it when it's your work. Then I'm going to go over the last section. So, on this section, they want us to determine, to classify each triangle as acute, right, or obtuse. And they gave us a little example or try to tell us where to start. We're always going to start with our longest side, which is our c. So for these set of problems, we have to say c squared, compare it to a squared plus b squared. Now we already know if it's equal, it's a right triangle. We just did that on the set before. If c squared is less than a squared plus b squared, then what type of triangle do we have? Great job. Acute. If you said acute, you're absolutely right. You have a acute triangle. And if c squared is greater than a squared plus b squared, then we would have an obtuse triangle. So that's what we're doing. We're comparing our angles, our hypotenuse squared with the sum of the other two squared. So on 3, we're starting with the larger side, which is c, which would be 6. So we're saying 6 squared, compare it to 3 squared plus 4 squared. Go ahead and substitute and solve it. So we know 6 squared, and I'm putting underneath there is 36. And then we got 9 and 16. When I go ahead and work that out, we get 36 and 25. 36 is greater than 25. So number 14 is an obtuse triangle. So what's our largest side on number 15? Yep, right here, our 16. 16 is the c. So we're going to do 16 squared, compare it to 9 squared, and 11 squared. So 16 squared, I believe I guess is 256. Yep, so we're going to write that underneath. 9 squared is our 81. 11 squares are 121. And so all we got to do is add our 81 to our 121. Look at that sum. That's 202. Compare that to 256. Again, 256 is greater than that. Since it's greater, again, we have obtuse. So I think you kind of got the hang of this. I did pretty well on this in class. So that is that. And then the last one, it's just a bonus question. Oh, that's some more, sorry. Some more comparing. So always start with your C. And then this section, the 31 is just a bonus. This would be a bonus. Okay. So please use the notes that you have in your spiral. Make sure you are getting this done. Pause the video, check. I'm going to do a couple more. And get this done. Be ready for a check tomorrow. All right, I'm hoping on this next one you did that, which gave you 49, and then 16 and 36, which ends up being 52. So 49 compared to 52 is less than, so we had a Q. And then if we look here, start with our C again. So we have 12 squared compared to our 6 squared and 8 squared. Yep. 36 plus 64. Want to compare the sum of those to our 12 squared. If this is less than, no, I'm sorry, it's greater than 144, greater than 100. So this would be an obtuse triangle. So you're going to take care of the remaining types of problems. Thanks for getting your homework done. If you have any questions, be sure to ask them in class.